So we are starting our Unit 4 on energy, forces, and motion, and we're in our textbook on page 249, reading to page 253. So we're going to start by learning about what energy is. So what is energy? It might be exciting to watch fireworks displays such as the one shown in figure 1. Over and over you hear the crack of explosions and see bursts of color in the night sky. Fireworks release energy when they explode. Energy is the ability to cause change. The energy in the fireworks cause the changes you see as bursting flashes of light and hear as loud booms. Energy also causes other changes. The plant in figure 1 uses the energy from the sun and makes food that it uses for growth and other processes. Who knows what that's called when they change or when they make food from the sun? Photosynthesis. Synthesize means to create. Photo means light, so it just means to create something from light. Energy can cause changes in the motions and positions of objects, such as the nail in figure 1. Can you think of other ways energy might cause changes? What do you guys think? What are other ways that energy might cause a change? So we thought of fireworks, we thought of hitting a nail. What do you think? Kicking a soccer ball, right? So making something move. You asked for this one. This is your favorite. You asked for it the second you get into my room. What? Candy or eating, right? That causes a change, doesn't it? Because without it, you wouldn't be able to function, really, or move. Yes? Huh? We will write all of it in the foldable when we start it, I promise. Okay. Kinetic energy. Have you ever been to a bowling alley? When you rolled the ball and it hit the pins, a change occurred. The pins fell over. This change occurred because the ball had a form of energy called kinetic energy. Kinetic energy is energy due to motion. All moving objects have kinetic energy. Kinetic energy and speed. An object's kinetic energy depends on its speed. The faster an object moves, the more kinetic energy it has. For example, the blue car has more kinetic energy than the green car because the blue car is moving faster, which kind of makes sense. Like it requires more motion for you to move faster, right? Like if I want to run faster, I physically have to move my legs faster, don't I? Okay. Kinetic energy and mass. Remember, mass and weight are not the same thing. Who knows the difference? Does anybody know the difference? We gonna learn today. You want to give it a shot? Go ahead. So that's how we measure it. Weight is the measurement of the force of gravity on you. So when I step on a scale, it's actually a measurement of the scale pushing down on me. I mean, the gravity pushing me down on the scale. Mass is the amount of matter inside of me, right? So the difference is if I was going to go to space, I would still have all of the same mass. I'm not going to go to space and lose a kidney or something like that. I'm still going to have all of the same mass. But because there's no gravity, I'm weightless. Does that make sense? There's a difference. So when we talk about kinetic energy and mass, we're talking about the amount of matter, solid, liquid, gas inside of an object. Moving object's kinetic energy also depends on its mass. If two objects move at the same speed, the object with more mass has more kinetic energy. For example, the truck and the green car are moving at the same speed, but the truck has more kinetic energy because it has more mass. Think about it like this. If an object has more mass, doesn't it require more kinetic energy for it to move? Right? Because I need more energy to actually move it. So the faster it moves, more kinetic energy. The more energy it takes to move it because it has more mass, right? The more kinetic energy. Does that make sense? Okay. Potential energy, stored energy. So the idea is it has the potential to move, but it's not moving yet. Energy can be present even if objects are not moving. If you hold a ball in your hand and then let go, the gravitational interaction between the ball and the earth causes a change to occur. Before you dropped the ball, it had a form of energy called potential energy. Potential energy is stored energy due to the interaction between objects or particles. I'm going to break that down even further. It has the potential to move, but it has not moved yet. Right? It's stored. It's not moving yet, but it could possibly move. Gravitational potential energy, elastic potential energy, and chemical potential energy are all forms of potential energy. So we're going to write these all in our foldable, and I'll go over specific examples, okay? So gravitational potential energy, what word do we see? What word do we see in gravitational potential energy that might give us insight as to what it might mean? What word do I see? What base word, Ayana? Gravitational or gravity, right? So what is gravity, by the way? What is gravity? Okay. The force that pushes us down. So this is the potential for something to fall because gravity could push it, okay? Even when you're just holding a book, gravitational potential energy is stored between the book and Earth. The girl shown in figure 3 increases the gravitational potential energy between her backpack and Earth by lifting the backpack higher from the ground. So it has more potential to fall at this point, doesn't it? Right? If I have something higher up on the ground, doesn't it have more potential to fall? If I'm standing, this happened to me when I was a kid. I was, you're gonna laugh at me though. I was standing on the toilet seat, okay? I was like, had a face painting. I had a face painting. I was like crying. I was trying to look in the mirror. I stood on the toilet seat and fell off and busted my head open, all right? But I could have very well just stood on the ground and gotten like a hand mirror, but I had more potential to fall when I stood on top of something, right? Because the height between me and the ground gave gravity the opportunity to push me back down, kick me while I'm down, right over. So the idea is the higher up I am, the greater potential I have to fall. Got it? The gravitational potential energy stored between an object and Earth depends on the object's weight and height. Dropping a bowling ball from a height of 1 meter causes a greater change than dropping a tennis ball from 1 meter because it has more mass, right? Because it's going to take more energy to move. Similarly, dropping a bowling ball from 3 meters causes a greater change than dropping the same bowling ball from only 1 meter. So the higher up it is, the more gravitational potential energy. The more mass it has, the more gravitational potential energy it takes. Everybody follow me? When we write it in our foldable, it'll be much easier to understand. And we'll have a reference page that I think is going to be really helpful too. Elastic potential energy. This is one of my favorites. When you stretch a rubber band, and I'll show you guys this demonstration when we do our foldable. But when you stretch a rubber band, it has another form of potential energy called elastic. I don't know about you guys, but you know that or you haven't noticed, but my belly is getting bigger, right? Because I'm having a baby, and I have to wear elastic pants, like you will on Thanksgiving, right? And it stretches. So it makes it easier for me to fit my big belly into my pants, right? Just like when you're so stuffed on Thanksgiving, you have to fit your belly in your pants, right? So you might wear elastic pants or sweatpants because you know your belly will be expanding, right? Everybody knows. So elastic potential energy is energy stored in objects that are compressed or stretched, such as a spring or a rubber band or your elastic sweatpants. When you release the end of a stretched rubber band, the stored elastic potential energy is transformed into kinetic energy. This transformation is obvious when it flies across the room. This one is my favorite. Chemical potential energy. It's your favorite too. And from here on out, I will not give you snack unless you ask for it properly. You must call it chemical potential energy from here on out. All right, so listen. Food, gasoline, and other substances are made of atoms joined together by chemical bonds. Chemical potential energy is energy stored in chemical bonds between atoms. Chemical potential energy is released when chemical reactions occur. Your body uses the chemical potential energy in foods for all its activities. People also use chemical potential energy in gasoline to power cars and buses. So like the idea is you're not going to move unless you eat, right? Have you ever like been so hungry you feel so weak? Okay, that's because your body needs fuel. Any form of fuel. That's firewood, gasoline, batteries, right? Food. Anything that could possibly fuel you or an object is going to be chemical potential energy because they're chemicals that are giving you the potential to move. So from here forth, you must ask for chemical potential energy. Can I please have some chemical potential energy, please? If you don't ask for it right, you don't get it. Don't forget it. Yep. If one, yes, yes. All right. So what I want to do is we're going to come back to this, and I want to start our foldable. We're going to start with those 3 forms of potential energy, okay? Now remember, before I forget, I want to show you that if you miss something on the foldable, it is on my website under dcsmscience6.weebly.com. We're now on what unit? 4. And then if you guys go down, look, there's the study guide. It's already ready for you. And look, there's already a YouTube video of doing the study guide. It's already there. And then a blank study guide as well. So you guys can kind of get ahead on things. Yep. So here's the foldable. In case we missed something, it's lots of drawing today. Lots of drawing today. All right, so bless you. I'm gonna bring my camera back and we're gonna make our foldable together. And the way that, bless you, the way that we make this foldable is we need 4 pieces of paper this time. And we are putting them about a fingernail width apart just to create little tabs. So I should be able to see the difference in the 4 tabs, and then folding them up. So I have a total . All right, on the front, do me a favor. I want you to label yours just like this. I want you to label yours just like this. Well, it doesn't have to be as colorful. I just put those colors there so that you know the difference between each tab. All right, so I want us to start with taking notes on the parts that we already read about. So this would be, we're going to open up the 2 types of energy and fold it down. What were the 2 types? One has to do with motion and one has to do with stored. Mazzy? Kinetic and potential. Very good. So kinetic energy and potential energy. I'm going to make a little chart. Which one of those was energy due to motion? Which one was energy due to motion, Caroline? Kinetic, very good. So this is energy of motion. And we said it depends on two things. Looking back on your reading, it said it depended on two things. Christian? Yep, it depends on speed and mass. We said that if it had more speed, did it have more or less kinetic energy? More, because I have to move my feet more, right? If I think about moving faster. It's all right, we're just learning it. All right, what about mass, Carlos? If I have more mass, is it more or less kinetic energy? More, very good. You have redeemed yourself. Very good. Potential energy is, Emerson? Stored energy, very good. This, it has, and this is the way I remember it, it has potential to move, but it's not moving yet. I do want to make a note to make sure you look at the other forms of energy tab, because that's where we're going to talk about the gravitational potential energy. Our favorite chemical potential energy and elastic potential energy. Where, baby? Speed, yes. The last thing I want to write on this is our definition of energy, which is the ability to cause change. This could be change in position or motion, but the ability to cause change. So I want us to flip to the other forms of energy tab, the one all the way at the top. Because we just talked about potential energy, right? So this one is a lot of writing, but that's why I want to, because we already started reading over it, I wanted to go over what we already read before we move on. All of these are going to be forms of potential energy, meaning that they're not moving yet. The first one, what was the first one that we read about? Look at your page. Gravitational. Gravitational potential energy. Our key word we said was gravity, right? We know that gravity is the force that pulls everything down to Earth. So gravitational potential energy would be the potential for something to fall. The potential for gravity to push something back down. Potential for gravity to push something down or something back down. AKA fall. This is anything that can fall. My rock pet Stacy is high up on the counter. Stacy has gravitational potential energy. I don't want to push you, Stacy. I feel like you're gonna break. My post-it notes. More gravitational potential energy. Now it has less because it's already fallen, right? So really it is the potential for something to fall. We said it was affected by two things. Does anybody remember? It's affected by two things. Emerson? Yep. So it's affected by height. So if it has more height, that means more gravitational potential energy. And the other was weight. If it has more weight, it also has more gravitational potential energy. The best example of this is when you're on a roller coaster. Yeah? So like here you are on a roller coaster, whee! And you're about to fall. This is like when you're at the very top. What would be the, so here's the highest point where you have the most gravitational potential energy. At what other point would you have gravitational potential energy in this roller coaster I just drew? Caroline? Yeah, at the top of the loop where you're like paused for like a second, right? When you're on an elevator, I don't know if you've ever done this. I don't know if you've ever done this, but when the elevator moves up and you feel it like kind of stop for a second, but then go back down and settle. When it goes up and stops for a second, I've always like jumped in the air to see if I can get some height. But that split second that you're up in the air, you know, you're frozen in time for a second, right? Here, somebody record me. Somebody record me doing this. Hold up, hold up. All right, here I go. If you watch this video, here's me. Hi, me. I'm taking forever. But watch when I jump. For a split second, you're going to see me freeze in the air. Good thing I'm wearing shorts under this. But do you see? For a split second, I'm in the air and frozen before I come back down. Can you kind of see that? Watch again. Thank goodness I'm wearing shorts under this. Frozen, and then I come back down. So for that split second when I'm in the air, before I come back down, I have gravitational potential energy because it takes the force of gravity to push me back down. Does that make sense? Okay. My second form of potential energy, so I've got gravity that's going to push me down. My second form is elastic. And instead of rewriting potential energy, I'm just going to say PE. PE, potential energy. This is energy that is stored in objects that are compressed or stretched. So compressed is like a slinky that's really close together, right? But if I pull that slinky apart, it's going to be flat. Right? But if you look, here's my rubber band is not being stretched or compressed, right? If I compress it and I let it go, it's going to go back to its normal shape, right? If I stretch it and let it go, it's going to go back to its normal shape. If I stretch it, right now it has potential to move, doesn't it? But it's not moving. The second I let it go, it flies across the room. So it transforms from that potential energy because it had the potential to move, right? You didn't see it? I had my hair tie, right? I'm not gonna undo my braids. It just looks too beautiful today. But this hair tie is stretched. But the second, you really think it's that long? No. But the second I take it out, it's gonna go back to its normal shape. So I'm stretching it, right? Same thing if I had the spring in your pen. When you click the spring in your pen, does it, and I unclick it, doesn't it go back to its normal shape? So when it's compressed, it goes back to its normal shape. So I'm stretching it, bink, and it didn't go across. But it has the potential to move based on whether it's compressed or stretched. So our examples here would be, what are some of the examples we just talked about? Somebody new. What's an example I just showed you? A rubber band. What are my mobile friends? What else is something you could think that we just talked about that is stretched or compressed? What did I just say? It has to do with one of these things. What do you think? Anybody have any ideas? Mazzy? Yep. I'm going to say a slinky, a pen spring, Miss Burley's elastic pants. All of those are examples. My elastic pants so that it can stretch. And our examples for gravitational potential energy, we just put a roller coaster. So if you don't know what that is, you might want to label it as a roller coaster. But that's why I said anything that has the potential to fall is our example. So if you need to write that, feel free. So anything for our example would be anything that can fall. Anything that can fall is gravitational because it has a pull to the Earth's surface. Yes. Oh, A balloon? For what? For which one? For gravitational or elastic? Yes, it would. A balloon would be one because it's rubber and it can stretch or compress. All right, and our last and our favorite is chemical potential energy, which is now what you have to ask for instead of snack. Okay, so chemical potential energy, I'm going to break it down. These are chemicals, and they're not really chemicals. They're just things that are made up of chemical bonds. Chemicals that have potential to give you energy. Or potential to make you move. Energy stored in chemical bonds. Any type of fuel. Any type of fuel is our example. Give me some examples of things that might give fuel. Carlos. So any type of food. So food. What else? I have a specific fuel in the morning. Your parents might too. Coffee, coffee. What kind of fuel do I use to get to school? Gasoline. What kind of fuel do plants use? The sun. Through photosynthesis. What about your phone? A battery. And then this used to be back in the day when how many of you ever seen like Titanic? Okay. So what were they doing at the bottom of the ship to make the ship move? What were they didn't have gasoline. What were they? Coal. So I'm going to say gas or fossil fuels here cuz coal. And what did you see at the bottom? What's something else that we could burn as fuel? Wood. Not fire necessarily, the wood in the fire. The wood in the fire. So any type of fuel is our example of chemical potential energy. If you're not a great drawer, that's okay. Now, if we look back to our reading, I can see that there's a page that gives me the other types of forms of energy. All of these are examples of kinetic because they involve motion. Mechanical, sound, thermal, electric, radiant or light because of radiation and light, and nuclear. We will not talk about nuclear this year, but as you can see in our foldable, we will talk about the rest. So let's work our way backwards. We're going to start with mechanical. This has to do with the total amount of potential and kinetic energy in an object. So this is the total amount of potential energy and kinetic energy in an object. So the idea, or objects. The idea is when an object has the potential to move and then moves. Just like that spring, right? It had the potential to move when I stretched it, and then I let it go, and then it moved, right? So when an object has the potential to move, and then it moves. The ability to move, really. My example, I don't know why I drew that star. My example is a car at a stop sign, and then it drives away, right? At one point it stopped, and then it keeps moving forward. So mechanical energy is just that idea that something was stopped and then continues to move. Does that make sense? The total amount of energy in an object. So we just went over mechanical. That was the sum or total amount of potential and kinetic energy in a system of objects. And they gave the example how potential energy, when somebody shoots a basketball, that it has the potential to move. And then even in that video I showed, at the very top, the maximum it can get, it's kind of frozen for a second and then continues to move again. Our next one is electrical. This has to do with electrical currents. So this is the energy an electric current carries. Fans, dishwashers, anything that is electrical. So in our foldable, we're just writing energy that an electric current carries. Bless you. See my plug? That's my plug. An electric current carries. So what were some of the examples that it showed us? What were some of the examples that it said in our reading that I just read out loud? Think about things that carry electricity. Okay, power lines. Okay, so if you don't know how to draw power lines, they're basically just T's. And then you like connect the dots. So I'm just gonna connect the dots. If you don't know how to draw that, you can just write power lines. What else did it say? What are you guys on all the time? Phones. A phone. It also gave us the example of a fan. And we could also say lightning. But there are plenty more examples. Anything, my laptop, the document camera, the owl, the TV. All of those have electrical currents. If you are not a great artist, I will not be, when I collect these, I'm not grading you on the pictures. It's more about you understanding. So if you want to draw maybe one of them and then write the other examples, that's okay too.
Can you scoot over a little bit?
Yeah.
Thank you.
You're welcome, love. Light energy is pretty self-explanatory. It is also known as, or AKA, radiant energy. When we think of like radiation or light from the sun, right? So what kind of waves do you think this is? What kind of waves if it's radiation? Emerson? Yep, the energy that electromagnetic waves carry. So what was the one example that it literally had the answer in it when we were going over heat transfer? Microwaves, radio waves, light waves. Now I remember when we were first going over heat transfer, I was talking about how heat and visible light are not the same thing. They're not. But they are the same, like same kind of waves, but I don't want you to think that all light is heat. Does that make sense? That's why I was distinguishing the two. So if you guys want to, you don't have to list all of these, but if you want, you can. What's the biggest one? The sun. So you don't have to draw them, like I said, but you do need to list them. The sun. We already listed this one, but if you want to draw it, you can. A microwave. A burger. A light bulb. A radio. But these are anything that you can think that's producing light. But we also know if you want to refer to it as radiant energy, anything that uses electromagnetic waves. So you can think about, there's another one that we didn't list, but it's actually an example of two different kinds. So light, well, what else? It uses electromagnetic waves and provides light. Okay, oven, I could think of what else? A fire, but a fire is also an example of thermal because it's giving you thermal energy. Because remember, they are different. So we're going to use that for our thermal energy example. What do you guys think thermal is? Knowing what the prefix thermo means, what do you think thermal is? Raising your hand. Somebody new. Somebody new. Bishop, what do you think? Heat. Very good. So I'm going to go to thermal. And we know that therm means heat. So this is also known as heat energy. This is energy that produces heat. Now remind me, does heat move from colder to warmer objects or from warmer to colder? Caroline? Yes, it moves from warm to cold because it wants everything to be the same temperature, just like when you're in your car, right? And you're sitting in the back seat and mom's all toasty in the front seat, but it's not hot for you yet. Give me some examples of thermal energy. We talked about some. Think about our heat transfer that we talked about. Emerson? Yeah. What's another one? So the sun can fall into two categories here. Actually three, because nuclear energy. But you'll get more into that in chemistry. What's another one? It might be in your house. Microwave is a stove, but that would be electrical. It would go from electrical to thermal. So we're going to talk about how heat can transform from one to another. We're going to start that next class. Yes? A fireplace, a heater, a hair dryer. But remember, all of those started as electrical. So we're going to talk about the law of conservation of energy in our next class. Because it starts as one thing and ends up as another. Does that make sense? Yes. I could say, now remember, this has a cord, so it's originally electrical, but we're going to talk about how it can, a hair dryer, but we're going to talk about how it starts as electrical and transforms. So we're not going to talk about the law of conservation of energy today. You will still need your foldable on Thursday when we go over it so that you guys know, because we will be practicing those energy conversions, meaning from one type of energy to another. And then last, but certainly not least, sound whenever you're ready.
It's raining.
I know. Sound. This is, and if I look back on my notes in our textbook, we had electrical was the energy that an electric current carries. Radiant is light waves, microwaves, radio waves, electromagnetic waves. So it's that energy inside those waves. Thermal is it says the sum of kinetic and potential energy that make up an object. But the idea is it's that heat that's inside the object. And sound energy, that energy that sound carries, vibrating objects. So what I want you guys to do is really quick, put your hand on your throat, like this. Put your hand on your throat and go la 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 la. Don't you feel the vibrations in your throat? Have you ever heard of them called vocal cords? That's because they're vibrating. That's what gives you your sound. So just like a guitar, and I'm about to show you guys, just like a guitar, this is the energy that sound carries through vibrations. So this could be me teaching, because you can hear my voice. Energy, energy. So this is like just talking or singing. A guitar. A stereo, the sound you hear from your stereo, yes? No, I actually have that dress. I have that dress. In my music video or in the song where I wrote them and shared with you guys, I'm wearing that. But if you guys, your mom says what? So if you look at this string, these strings they're stretched, but if I pluck it, you can see it vibrate. The second I stop the vibration, the sound stops. Watch. Same thing here, Brennan. I don't know what you're doing. So, same thing here. You see this bowl? Oh, there's stuff inside of it. The second that I stop the vibration, the sound stops. Watch. Right? So this is to the tune of Kiss the Girl. It's on my YouTube channel, which is Miss Burley. And then the first one that you guys see on there is the one that I'm challenging you guys to write a verse. If you write a verse, I will give you extra credit. I will add 1 point to your lowest test grade. I will show you the completed version with student examples and I haven't played this in a year, so bear with me. Here we go. Wrong. There we go. like the way that sounds. I don't like, it's out of tune. Hold on, I gotta tune it. There we go. Yes, it's brighter, thanks to Thomas Edison. We convert electricity into light waves. Turn on your lamp at night using a plug. That's right, it's electrical energy. Yes, you feel it. Thermal energy, it's true. Feeling all the heat on you, close to the fire. I used wood as fuel, and I learned in school that's chemical energy. Sha-la-la-la-la-la, hear me sing while I play these strings, they are vibrating. Sha-la-la-la-la-la, energy, that's how you hear me, it's sound energy. Now's your moment, show me what you can do. Come up with a verse or two to teach me what you know. I'm excited to see how creative you can be. Come on and show me. Yay! No, really, I will challenge you guys. The video with me singing much better is on my YouTube channel. But check it out. We're going to be practicing this for at least the next week. Bye, guys.